Here we go. We're going to be multiplying matrices. Well, first of all, you have to remember on matrices what the rows and the columns are. If I said 2, 4, negative 3, 1, and 2, 7, you should know that's a what by what. Don't say it out loud. Please copy this down and write underneath it. It's like a 3 by 2 or it's a 2 by 3. You have to know which is which. Which goes first? Don't say it. Write it. I'll give you this hint. Rows are always first. It's always RC. So what do you think?
3, 2.
3 by 2 is correct. And you have a question?
We're going to do a test correction.
Oh, what about test corrections?
When are we going to do that?
Well, you have to ask in class last 10 minutes. We don't have like a whole day for corrections. Yes. So if you haven't already, I don't want to hand the tests back today for everybody because there's a ton of kids missing and I would just have to re-hand them all back out again later. So I will get those back to you a different day. For right now, last 10 minutes is always a good time to do corrections. Or Thursday of this week, a couple days from now in the morning. All right, so we've got this matrix. And if this was as easy, if it was just like, oh, put a 3 outside, don't even do it. That'd be too easy. It would just mean multiply everything by 3. That's called scale multiplication. And that is incredibly easy. If you can't times everything by 3, then you're in the wrong class. But if I put another matrix right here, then that's a lot harder to multiply out. And I'll show you how, but you're going to want to pay attention. 1, 0, 2, 3, 1, negative 2. We'll have one negative number in there just to practice that. All right, well, what's that? That is a what by what? Well, it's exactly the same as the other one. But this is an important point. If this is a 3 by 2 matrix, yes, if the matrices are exactly the same as each other, then they will multiply. But if they aren't exactly the same, sometimes they will still multiply. Like, it's weird. You can take a 3 by 2 and another matrix that's completely different than this, and you'll be able to multiply them. So actually, I said this wrong. I was wrong, and I apologize. For anybody that knows how to multiply matrices, you'd be offended right now. What I said is that if they are exactly the same as each other, that they would always work. That is not correct. If it's a square matrix, which is the most common one, like 2, 1, 4, 3, and another square matrix, then they will always multiply. If they're square, or like, so if it's like a 3 by 3, 1, 1, 1, 1, 1, that's a 3 by 3 matrix now. 4, 1, 0, 1, 0. Now a square matrix times a square matrix will always just work. But here's how you can tell if yours is going to work. You should look at these numbers. Please circle those numbers. If those numbers match, if they are the same as each other, then these matrices can be multiplied. So, is 2 the same as 3? No, it's not. Then these matrices can't even be multiplied. It is impossible. The answer is no solution. You would think if you were just going to do like this times this, and you know each of them times each other, that it would be that. It's not that simple. It's much more complicated than that. So these they won't even match. So they will not multiply. All right. So we're going to give you now I'm going to change it so that it will work. Everybody erase the bottom 2 like that. And then we're going to add a column. And this very first number, we need some negative number in here. So let's put a negative 2 right there. Now, would you agree we no longer have a 3 by 2 matrix? What is this new matrix?
2 by 3.
2 by 3. It's a 2 by 3. What did I say about these two numbers? They needed to match. Do you get that they match now? Now it can be multiplied. All right, so the first part on the ACT, when I've seen this question, it's usually about half the time they're asking about which of the matrices can be multiplied. And how you tell? If the inside numbers match. I don't want to try to make you memorize if the number of columns in the first matrix matches the number of rows in the second matrix, then you'll never remember that. But you can remember the ones on the inside match. See, this one can be multiplied. All right, next thing, the answer will be a this by this. Do you get that you probably don't look exactly like your mom or your dad? You probably look a little different than both of them. Now, sometimes there's a family resemblance, and you like look more like your mom or more like your dad. But my point, the child matrix here isn't going to look like either parent. The answer to this thing is not a 3 by 2 matrix, and it's not a 2 by 3 matrix. It's a what?
3 by 3.
It's a 3 by 3. That's the point. This by this. All right. So put equals, and then we have to make little Easter eggs for each part of the answer. So we make a 3 by 3 matrix of Easter eggs that you're going to fill in with the answers in a second here. Those are your 9 answers. That is a 3 by 3 matrix. Okay, catch up to me. Some of you guys are a little too relaxed today. Lock in. So, how did I tell these were going to multiply? Because the inside ones matched. How could I tell that it was going to be a 3 by 3 matrix? Because the outside ones were a 3 by 3. That's how I knew it was going to be a 3 by 3 matrix, because these numbers here on the outside told me it was going to be a 3 by 3. Okay, so now how do I get these actual numbers? Well, yes, question.
So if like you switched which one was on left and which one was on the right?
It changes it completely.
Okay.
Sometimes you can't even multiply them. So what she's saying is, what if you just move this one over to the other side? Could they multiply them then? Not necessarily. That's weird too, isn't it? Normally if you multiply, if you can do 2 times 8, then you can do 8 times 2. Not with matrices. You have to line them up and look at these numbers and go, okay, do these numbers match? Yes, then I can multiply it. And my answer will be a 3 by 3. So here's my matrix of little eggs, and I'm going to say, what should go in that little egg? That number that goes there. Well, if you can name it, then you can know what to do to get it. Would you agree that that very first spot would be row 1, column 1? That is row 1, and it's in column 1. So everybody write R1, C1. That spot is row 1, column 1. So now you're going to use row 1 from the first matrix. Just a second, I want to clean this up a little bit here. So I'm going to use row 1 from the first matrix. And in fact, I'm going to even call it the row matrix. You know how it's always rows, then columns? Well, that first matrix is called the row matrix. We'll only use rows from that matrix. To make sure you understand what I mean, these are the rows. This is row 1, this is row 2, and this is row 3. We will only use the rows from that. And the column matrix, of course, we're only going to use columns. So we'll either use the column 1, or we'll use column 2, or use column 3. And which ones do you think we're going to use? Becca? To get this answer right here, which ones should I use? Hint? You're going to use row 1 and column 1. So this one is the only place you can get rows from. That's row 1. and that's column 1. Now, we're going to use those numbers. The whole point of this is multiplication. This is the point where we finally actually multiply something. So that very, very first number, little 2 there in front, goes with the negative 2, and you multiply them. And so I'm going to zoom in on this now. And I'm going to use this 2 and this negative 2. And what is 2 times negative 2? Negative 4. Put that in the little circle. Plus, the other 2 numbers have to be multiplied. And notice I put a plus in between them. The other 2 numbers are the 4 and the 0. What's 4 times 0? 0. What's negative 4 plus the 0? Negative 4. That's our first answer. It's negative 4. All right, how did I do that again? I just had to know my address. That spot right there is that spot. Row 1, column 1? Well, definitely not. Is it row 1 still?
No. Yeah.
It is row 1. Is it column 1 still? No, it's column 2. That's row 1 and column 2. Then that's what you're going to use. Row 1 with column 2. This is our row matrix over here. And I'm going to switch colors. I'm going to use row. Wait a minute. Was I supposed to use row 1? Yes. This guy's address right here tells me what to use. I'm supposed to be using row 1 and column 2. Row 1 is this one. Column 2, I'm going to change now. This is column 2. So that pink one, would you please figure out what the answer is that I'm going to put here now? Multiply row 1 with column 2. Tate, what 2 numbers are going to get multiplied again?
3 and 1.
We're using row 1 and column 2. Do you see row 1 over here?
I don't know.
See what I'm circling? What's that?
2 and 4.
Okay. And here's column 2. So use the 2 and the 4 and the 3 and the 1. You can do this. What do you do?
I don't know.
Okay. The 2 times the 3 and the 4 times the 1. So 2 times 3 is 6. 4 times 1 is 4. I got a 6 and a 4. What do you think I should do with them?
10.
Yeah, I'm going to get 10. All right. Got that written down yet? Good. Stay caught up. Next one. We're just going to keep practicing this until it becomes like, oh, okay, it's obvious now. Well, what's the address for that spot? Yoakum.
Row 1, column 3.
Row 1, column 3. Okay, so now I'm going to go over here to row 1. We're still using this one. And I know it's getting a little messy in there, so I'm going to clean this up. This is a 2 right here. So the 2 and the 4, but now we're using column 3, which is this one. So, what do you do?
2 times 4.
2 times the 4, this 2 times this 4, which makes?
8.
And then?
The 4 times the 8.
This 4 here times the 8, which is 32. And what do you think I should do with the 8 and the 32?
Add them.
What do you get? 32 plus 8.
40.
40. Bingo. How many of you feel like you're getting this? Okay. Next one. Jack, what's that spot right there? This egg right here. Row 2, column 1. Okay. Finally, we moved on to row 2. So I'm going to erase all of this circling around row 1. Here's row 2. Albright.
Yes, sir.
Row 2 and what is the other one?
Column 1. You do negative 3 times negative 2 and then 1 times 0, which is 6.
All right, positive 6 and 0 makes 6. You got it. Nice job. You guys getting this?
Yes.
All right. Tate, that one. Row what? Column what?
Row 2, column 2.
Good. Over in the row matrix, which ones are we using here?
Negative 3 and 1.
Yep. And the column 2 also.
3 and 1.
Yep. Multiply them out.
So would the end be negative 5? Oh, wait, no.
Don't think so. Negative 3 times negative 3, yep, is 9. Negative 9 plus the 1.
8. Oh, negative 8.
Negative 8. There it is. You're getting there. You're better than you were last time I called on you. All right. So in the back row, let's go into the corner pocket. What do you got? What's this one? Oh no, do not the final answer, but what's row, what column?
Row 2, column
2, column 3. Good. Now I'll look at your answer. Row 2, column 3. That's this one and this one. So then I got negative 12 and positive 8. Negative 12, positive 8. Did you say negative 4?
Yeah.
You were correct. Nice job. Well, we got to at least finish this one. Afton, can you tell me what this spot right here is?
Row 3, column 1.
Yep. Row 3, column 1. Afton, which one's row 3?
The bottom one.
So what are the numbers in there in row 3?
2 and 7.
Okay, 2 and 7 goes with column 1.
Negative 2 and 0.
Yep. Multiply them out, what do you get?
You get negative 4 plus
Yep, what's negative 4 plus 0?
negative 4.
Negative 4. Back around. This spot's name is?
Row 3, column 2.
Good. Here's row 3. Here's column 2. What are you going to do?
2 times 3.
Is 6 plus
7 times 1, 7.
6 plus 7?
13.
13 is correct. Kate, last spot.
R3, C3.
Nice. Here's R3. Here's C3. What do you do?
2 times 4.
2 times 4 is 8.
7 times 8, 56.
56 and 8. 56, I think it's 64. Raise your hand if you had 64 before we said it. Nice job. All right, you've learned to multiply matrices. That's how you do it. So let me just talk you through a couple things. So imagine you get it all set up and you realize you have a 2x4 and a 3x4. Is that one going to work?
No.
Nope. These have to match for it to work. You just say no solution. It doesn't work. Okay? So what if it's 2x4 and a 4x4? Will that work? Yeah, because those match. And so then if it is that, the answer will be a 2x4. If you had just seen that, 2 times 4 and 4 times 4 equals 2 times 4, it'd be really weird, but I think if you understand that we're just trying to figure out what kind of matrix it is, the circled thing says that's going to work. And the answer is, your answer will be a 2x4 matrix. All right, so let's actually start the homework. Find the homework. Can you read me number 1, please? Leah Martin.
Write undefined for expressions that are undefined.
Okay, so we want to know if it's going to work or not work. Undefined just means that it won't multiply. Okay, so what do they give us?
They give you 0 to,
Are you reading from left to right?
yeah,
Okay, 0, 2,
-2 and -5.
like that?
Yeah.
Okay, then is that a 2 by 2 matrix?
Yeah.
I would agree it's a 2 by 2. Okay, then what else?
Multiply by 6 by 6 and -6. On top.
Oh, okay, I'm sorry. You're giving me another matrix.
Yeah.
6, -6.
And then 3 and 0.
Thank you. Now, that's a 2 by 2 matrix also, right? So will this multiply? Yeah, because these match. And what will the answer be? A 2 by 2, because of the outside numbers. Now, do they want us to actually multiply them, Leah, or do they just want to know if it works?
It's a simplify.
Okay, so then we actually have to multiply them. So then I'm going to make myself 4 Easter eggs. Do you have to have Easter eggs? No, you don't. I'm just trying to make sure you get what it looks like. I know this is a 2 by 2 matrix answer, so I think the Easter eggs are handy for making sure you do the right kind of answer. And then I just go through each one and go, what's its address? Well, that's row 1, column 1. So I'm going to use row 1 here and column 1 there. 6 times 0, 0. 2 times 3 is 6. I got a 0, I got a 6. I add them. Anybody have a 6 there before I said it? I think it's 6, isn't it? Okay. Now I'm going to go to this spot. That's row 1, column 2, I think. Right? Jack, can you tell me what the numbers are for row 1? Because we're doing this right here.
Yeah.
What's row 1?
0 and 2.
Yep. What's column 2?
-6 and 0.
Yep. If you're going to do these two, what times what plus what times what?
0 times -6 and 2 times
0 times -6 is 0 plus 2 times 0 is 0. 0 plus 0 is 0. Just a 0 in that one. Chase, Rizik, what's this spot right here?
Row 2, column 1.
Nice. What are the numbers for row 2?
-2 and 5.
-2, -5, yes. Right? Okay. And then times it by column 1.
And then I got -27.
Wait, you gotta tell us what you did. So there's column 1, which is 6, 3. So then what'd you do?
Multiply -2 by 6.
Which makes -12.
And then -5 by 3, and then add them together.
-12 and -15 makes?
-27.
Yep. Okay, I think you're getting the idea. I want to look at the one before I decide which ones to assign. Keep life simple and just do the odd problems. 1, 3, 5, 7, 9. On problem 3 then. Afton, wait, what?
There are also 4 review questions that are added and subtracted at the bottom.
Okay.
Should we do 2 of them?
I only saw it go through problem 14 or something.
Yeah.
Yep, so we're including those. So just odds the whole way. Okay, number 3, Chase Rizik, could you read me, what kind of a matrix is it? A what by what and a what by what?
2 by 2 and 2 by 2.
It's a 2 by 2 and a 2 by 2. Well, that definitely works. Remember, square ones always work. But that's going to tell me the answer is a 2 by 2. Okay, what's the first 2 by 2 matrix?
-5, -5, and then -1 and 2.
Like that?
Yep.
Good. And the other one?
-2, -3, and 3 is 5.
Nice. And then the answer is a 2 by 2. So I would make 4 Easter eggs like this. I think you've got the idea. If you need help, come on up and ask. These are tricky. I get that they're tricky. And if you're sitting there going, I really don't get this, walk up, I'll help you. That's all I got for you for today. Just do the odds.